Schedule 40 polyvinyl chloride, or PVC, is not suitable for use above ground for 4,160 volts alternating current, or VAC, 500 kc cable for several reasons. Firstly, Schedule 40 PVC is not ultraviolet or UV resistant and will degrade rapidly when exposed to direct sunlight. This degradation causes the PVC to become brittle and susceptible to cracking. Sunlight contains UV radiation, which breaks down the chemical bonds in PVC, leading to discoloration, loss of flexibility, and ultimately structural failure. This process is accelerated with prolonged exposure, making Schedule 40 PVC an unreliable choice for outdoor applications where sunlight is prevalent. Secondly, the temperature range of Schedule 40 PVC is typically between -40°C and 60°C. This temperature range may not be sufficient for outdoor use in all climates. Extreme temperatures can cause the PVC to soften or become rigid, significantly affecting its structural integrity and performance. In colder climates, PVC can become brittle and prone to cracking under stress, while in hotter climates, it may soften and deform, compromising its ability to protect the electrical conductors. Thirdly, Schedule 40 PVC is generally designed for underground applications and may not possess sufficient mechanical strength for above-ground installations. Above-ground conduits are exposed to wind, physical impacts, and other mechanical forces that can compromise the integrity of the conduit system. Schedule 40 PVC, being less robust than alternatives like rigid metal conduit, or RMC, or intermediate metal conduit, or IMC, is more susceptible to damage, potentially exposing the conductors and creating safety hazards. The National Electrical Code, or NEC, and other electrical standards specifically prohibit the use of PVC conduit for above-ground installations in wet locations or areas exposed to sunlight. The NEC provides detailed guidelines on the appropriate use of different types of conduit based on their material properties and intended applications. These regulations are in place to ensure electrical safety and prevent premature failure of electrical systems due to environmental factors. Failing to comply with these standards can result in code violations, fines, and potential liability in the event of an accident or system failure. For above-ground installations of 4,160 volts alternating current, or VAC, 500 kc cable, several alternative materials would be more suitable. These alternatives provide enhanced protection against UV radiation, temperature extremes, and mechanical stress. One suitable alternative is galvanized steel conduit. Galvanized steel conduit offers excellent mechanical strength and resistance to corrosion. The galvanization process involves coating the steel with a layer of zinc, which provides a protective barrier against rust and other forms of corrosion. This makes galvanized steel conduit suitable for both indoor and outdoor applications, particularly in environments where moisture or chemical exposure is a concern. Additionally, its robust construction provides superior protection against physical damage, ensuring the long-term reliability of the electrical system. Another suitable alternative is rigid metal conduit, or RMC. Rigid metal conduit, or RMC, is a heavy-duty option that provides superior protection against physical damage and environmental factors. It is typically made of steel or aluminum and is designed to withstand significant mechanical stress, making it ideal for applications where the conduit is exposed to potential impacts or heavy loads. RMC is also highly resistant to corrosion, making it suitable for use in harsh environments. Intermediate metal conduit, or IMC, is another option. Intermediate metal conduit, or IMC, is a lighter weight alternative to rigid metal conduit, or RMC, offering a balance between strength and cost-effectiveness. IMC is made of galvanized steel and provides good protection against physical damage and corrosion. It is suitable for use in a variety of applications, including both indoor and outdoor installations, and is often used in commercial and industrial settings where a durable and reliable conduit system is required. UV-resistant non-metallic conduit, such as Schedule 80 PVC or fiberglass conduit, is another suitable alternative. Schedule 80 PVC conduit is a thicker-walled version of Schedule 40 PVC, providing increased mechanical strength and resistance to impact. It is also available in UV-resistant formulations, making it suitable for outdoor applications where exposure to sunlight is a concern. Fiberglass conduit offers excellent resistance to corrosion, chemicals, and extreme temperatures. It is lightweight and easy to install, making it a popular choice for a variety of applications, particularly in harsh or corrosive environments. When selecting and installing an electrical conduit, it is crucial to adhere to the manufacturer's specifications and electrical codes. These guidelines provide important information on the proper installation techniques, load-bearing capacity, and environmental limitations of each type of conduit. Failure to follow these guidelines can compromise the integrity of the electrical system and create safety hazards. Proper installation techniques include ensuring that the conduit is adequately supported, properly grounded, and securely connected to electrical boxes and fittings. Following the manufacturer's specifications ensures that the conduit is used within its intended limitations, preventing premature failure or damage. Failure to adhere to these guidelines can pose significant safety hazards and compromise the integrity of the electrical system. Using inappropriate materials or improper installation techniques can lead to electrical shorts, fires, and other dangerous conditions. It can also result in costly repairs and downtime, as well as potential liability in the event of an accident or system failure. Therefore, it is essential to prioritize safety and compliance when working with electrical systems. In summary, Schedule 40 PVC is not appropriate for above-ground use with high-voltage cables due to its susceptibility to UV degradation, temperature limitations, and inadequate mechanical strength. Suitable alternatives like galvanized steel conduit, rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and UV-resistant non-metallic conduits should be considered to ensure safe and reliable electrical installation. Adhering to manufacturer's specifications and electrical codes is crucial to prevent hazards and maintain system integrity. The selection of appropriate conduit materials is a critical aspect of electrical system design and installation. It directly impacts the safety, reliability, and longevity of the electrical system. By understanding the properties and limitations of different conduit materials and adhering to industry standards and best practices, electrical professionals can ensure that electrical systems are installed safely and effectively. The consequences of using inappropriate conduit materials can be severe, ranging from minor inconveniences to catastrophic failures. Therefore, it is essential to prioritize careful planning and material selection in every electrical installation project. The National Electrical Code, or NEC, serves as the cornerstone of electrical safety in the United States. It provides comprehensive guidelines for the safe installation and maintenance of electrical systems. The NEC is updated every 3 years to reflect the latest advancements in technology and address emerging safety concerns. Compliance with the NEC is mandatory in most jurisdictions, and failure to adhere to its requirements can result in legal penalties and increased risk of accidents. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed specifications for the types of materials and equipment that can be used in different applications, as well as the proper installation techniques to ensure safety and reliability. In addition to the NEC, other industry standards and best practices provide valuable guidance for electrical professionals. These resources offer insights into specific applications and address topics not covered in detail by the NEC. Staying up to date with the latest industry standards and best practices is essential for maintaining competence and ensuring the highest level of safety in electrical work. Electrical safety is a shared responsibility that requires the commitment of all stakeholders, including electrical contractors, engineers, inspectors, and equipment manufacturers. By working together to promote safety awareness and adhere to established standards, we can create a safer environment for everyone. Regular training and education are essential for electrical professionals to stay informed about the latest safety practices and technological advancements. Continuing education courses, workshops, and seminars provide opportunities for professionals to enhance their skills and knowledge, ensuring that they are equipped to handle the challenges of modern electrical systems. Furthermore, Promoting a culture of safety within electrical organizations is crucial for preventing accidents and injuries. This includes implementing safety programs, conducting regular safety audits, and encouraging employees to report potential hazards. By prioritizing safety at all levels of the organization, we can create a work environment where safety is valued and respected. In conclusion, the proper selection and installation of electrical conduit are essential for ensuring the safety, reliability, and longevity of electrical systems. By understanding the properties and the limitations of different conduit materials, adhering to industry standards and best practices, and promoting a culture of safety, electrical professionals can minimize the risk of accidents and create a safer environment for everyone. The use of Schedule 40 PVC for above-ground, high-voltage cable installations is not recommended due to its susceptibility to UV degradation, temperature limitations, and inadequate mechanical strength. Alternatives such as galvanized steel conduit, rigid metal conduit or RMC, intermediate metal conduit or IMC, and UV-resistant non-metallic conduit should be considered to ensure a safe and reliable electrical installation. Adhering to manufacturer's specifications and electrical codes is crucial to prevent hazards and maintain system integrity. The integrity of the electrical system also depends on proper grounding. Grounding provides a safe path for fault current to return to the source, minimizing the risk of electric shock and equipment damage. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, as well as the methods for connecting grounding electrodes. Proper grounding is essential for protecting people and equipment from electrical hazards. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. These devices protect electrical systems from damage caused by excessive current and prevent the risk of fire. The NEC specifies the required overcurrent protection for different types of electrical circuits and equipment. Regular inspection and maintenance of electrical systems are essential for identifying and addressing potential problems before they lead to accidents or equipment failures. Inspection should be conducted by qualified professionals and should include a thorough examination of all electrical components, including wiring, conduit, overcurrent protection devices, and grounding systems. Maintenance should include cleaning, tightening connections, and replacing worn or damaged components. The environmental conditions in which electrical systems are installed can significantly impact their performance and lifespan. Factors such as temperature, humidity, and exposure to corrosive substances can accelerate the degradation of electrical components and increase the risk of failures. When designing and installing electrical systems, it is important to consider the environmental conditions and select materials and equipment that are suitable for the specific environment. Proper ventilation and temperature control can help to prevent overheating and extend the lifespan of electrical components. In corrosive environments, the use of corrosion-resistant materials and coatings can help to protect electrical equipment from damage. The selection of appropriate wiring methods is another important consideration in electrical system design. The NEC specifies the types of wiring methods that are permitted for different applications based on factors such as voltage, current, and environmental conditions. Wiring methods include conduit, cable, and open wiring. Each wiring method has its own advantages and disadvantages, and the selection of the appropriate wiring method should be based on a careful evaluation of the specific requirements of the application. Proper installation of wiring is essential for ensuring safety and reliability. Wiring should be installed in accordance with the NEC and should be protected from physical damage. Connections should be made using approved methods and should be properly tightened to prevent loose connections, which can lead to overheating and electrical fires. The use of appropriate tools and equipment is essential for performing electrical work safely and effectively. The electrical workers should be trained in the proper use of all tools and equipment and should follow all safety precautions. Tools and equipment should be regularly inspected and maintained to ensure that they are in good working condition. The lockout/tagout procedure is a critical safety practice that is used to prevent accidental energization of electrical equipment during maintenance or repair. The lockout/tagout procedure involves isolating the electrical equipment from its power source and attaching a lock and tag to the disconnect switch to prevent it from being turned on. The lockout/tagout procedure ensures that the equipment cannot be accidentally energized while workers are performing maintenance or repair, preventing the risk of electric shock and other injuries. Electrical safety is a continuous process that requires ongoing vigilance and attention to detail. By following established safety practices, using appropriate tools and equipment, and staying informed about the latest safety standards, electrical professionals can minimize the risk of accidents and create a safer environment for themselves and others. In addition to the technical aspects of electrical safety, it is also important to consider the human factors that can contribute to accidents and injuries. Factors such as fatigue, stress, and complacency can impair judgment and increase the risk of errors. Electrical workers should be aware of these human factors and should take steps to mitigate their impact. Adequate rest, stress management techniques, and a commitment to following safety procedures can help to reduce the risk of accidents and injuries. Communication is also essential for electrical safety. Electrical workers should communicate clearly and effectively with each other and with other workers on the job site. This includes discussing potential hazards, coordinating work activities, and providing warnings about potential dangers. Effective communication can help to prevent misunderstandings and errors that can lead to accidents and injuries. The use of personal protective equipment, or PPE, is another important aspect of electrical safety. PPE includes items such as safety glasses, gloves, and arc-rated clothing. PPE is designed to protect workers from electrical hazards such as electric shock, arc flash, and burns. The type of PPE that is required for a particular task depends on the specific hazards that are present. Electrical workers should be trained in the proper use of PPE and should always wear the appropriate PPE when performing electrical work. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates a high-energy electrical arc. Arc flash can cause severe burns, blindness, and even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings to alert workers to the potential danger. Electrical workers should be trained in arc flash safety and should follow all safety precautions to minimize the risk of arc flash injuries. Electrical safety is a shared responsibility that requires the commitment of all stakeholders, including electrical contractors, engineers, inspectors, and equipment manufacturers. By working together to promote safety awareness and adhere to established standards, we can create a safer environment for everyone. The importance of regular training and education cannot be overstated. It's not just about ticking boxes or meeting minimum requirements, it's about fostering a culture of continuous learning and improvement. Technologies and regulations evolve, so staying current is paramount. This not only enhances individual skills but also elevates the overall competence of the workforce. Companies that invest in comprehensive training programs tend to have lower accident rates and higher productivity levels. Effective training should incorporate both theoretical knowledge and hands-on practical experience. Simulating real-world scenarios helps to reinforce learning and allows individuals to develop the necessary skills to handle challenging situations safely and confidently. Furthermore, training should be tailored to the specific needs of the job and the individual's skill level. One-size-fits-all approaches are often ineffective and can leave gaps in knowledge and competence. Mentorship programs can also be valuable in providing guidance and support to less experienced workers. Pairing experienced professionals with newer employees allows for the transfer of knowledge and skills in a practical and supportive environment. Mentors can provide valuable insights into best practices and help to instill a strong safety culture. Creating a positive safety culture requires more than just implementing rules and regulations. It requires a fundamental shift in mindset where safety is seen as a core value rather than just a compliance issue. This involves fostering open communication, encouraging employees to report potential hazards without fear of reprisal, and recognizing and rewarding safe behavior. Management leadership plays a crucial role in shaping the safety culture. When leaders demonstrate a genuine commitment to safety, it sends a clear message that safety is a priority. This includes actively participating in safety meetings, promoting safety initiatives, and holding themselves and others accountable for safe behavior. A strong safety culture also involves empowering employees to take ownership of their own safety and the safety of those around them. This includes encouraging employees to speak up if they see something unsafe and providing them with the authority to stop work if they feel that conditions are unsafe. By empowering employees to take control of their own safety, we can create a more proactive and resilient safety culture. Regular safety audits and inspections are essential for identifying potential hazards and ensuring that safety procedures are being followed. Audits should be conducted by qualified professionals and should cover all aspects of the electrical system, from wiring and grounding to overcurrent protection and equipment maintenance. Inspections should be conducted on a regular basis, and any deficiencies that are identified should be promptly corrected. The findings of safety audits and inspections should be communicated to all relevant personnel, and action plans should be developed to address any areas of concern. This ensures that safety issues are not only identified but also resolved in a timely and effective manner. The development of emergency response plans is another critical aspect of electrical safety. Emergency response plans should outline the procedures to be followed in the event of an electrical accident or other emergency. This includes procedures for shutting down equipment, providing first aid, and contacting emergency services. Emergency response plans should be regularly reviewed and updated, and all employees should be trained in the procedures to be followed. Conducting regular drills can help to ensure that employees are familiar with emergency response plans and are able to respond quickly and effectively in the event of an emergency. The investigation of electrical accidents and incidents is essential for identifying the root causes of accidents and preventing future occurrences. Accident investigations should be conducted by qualified professionals and should involve a thorough review of the circumstances surrounding the accident, including the equipment involved, the procedures followed, and the training and experience of the personnel involved. The findings of accident investigations should be used to develop corrective actions to address the root causes of the accident and prevent similar accidents from happening in the future. The sharing of lessons learned from accidents and incidents is also important for promoting electrical safety. By sharing information about accidents and incidents, we can help to raise awareness of potential hazards and prevent similar accidents from occurring in other organizations. Lessons learned can be shared through safety alerts, training programs, and industry conferences. The NEC serves as a valuable resource for electrical safety information. The NEC provides detailed requirements for the safe installation and maintenance of electrical systems. It is important for electrical professionals to be familiar with the requirements of the NEC and to follow them carefully when performing electrical work. The NEC is updated every 3 years, so it is important to stay current with the latest edition. In addition to the NEC, other industry standards and best practices provide valuable guidance for electrical professionals. These resources offer insights into specific applications and address topics not covered in detail by the NEC. Staying up to date with the latest industry standards and best practices is essential for maintaining competence and ensuring the highest level of safety in electrical work. In conclusion, electrical safety is a multifaceted and ongoing endeavor that demands unwavering commitment and vigilance from all stakeholders. By prioritizing safety in every aspect of electrical work, adhering to established standards and best practices, and fostering a culture of continuous improvement, we can collectively minimize the risk of accidents and create a safer environment for electrical professionals and the communities they serve.